This second lesson in Chapter 6 is about multiplying and dividing radical expressions. This is a very difficult lesson. You may want to watch this more than once. Here is a joke told by George Bush, and if you want to read it, go ahead and hit pause. Okay, in order to simplify radical expressions, the one thing you need to know is that if you have two separate radicals, like the nth root of a and the nth root of b, as long as they have the same index here, you can combine them into one radical. So for example, the square root of 2 times the square root of 3 is the same answer as the square root of 2 times 3, or the square root of 6. And down here on the bottom, the cube root of 4 times the cube root of 5 would be the same thing as the cube root of 20. So if you keep that in mind, you can simplify radicals. So here are some radicals to simplify. In our first example here, we have the cube root of 6 and the square root of 2. Because the index does not match, then we cannot simplify that. And so in simplified form, it's just what it was to begin with. We can't simplify that. Second example, we do have matching indices, cube root, which means we can multiply radicands. So we get cube root of -8, and the cube root of -8 is -2. Notice that the answer is negative. We get one solution only because the index was odd and the radicand was negative, so our answer is -2. Okay, this is where it gets more challenging. If we're trying to simplify the cube root of 54x to the 5th, it doesn't come out to simple whole answers. So we have to factor. So we're going to take our 54 here and factor it. 54 is 6 times 9. 6 is 2 times 3. 9 is 3 times 3. So what we notice is that 54 is equal to 2 times 3 times 3 times 3. Since we're looking for a cube root, that means we're looking for groups of 3. Since we have a group of 3 here, we can take the cube root of 3 cubed. And that will just give us 3. So we're going to have 3, and we're going to still have cube root of 2. Okay, that's our numbers, our coefficient numbers. Now we still have x to the 5th. X to the 5th means we have 5 x's. Again, we have an index of 3, so we're looking for groups of 3. We have one group of 3, so that would be x to the 1st power, meaning x, one group. And then we have 2 x's left over. Since that's not a perfect cube, we're going to put it back in the radical as x squared. So there's our final answer in simplified form. This is a little bit confusing, but give it a try. I think you can do it. In this next example, we have 128. 128 is 2 times 64. 64 is actually a perfect cube. It turns out to be 4 times 4 times 4 is 64. We could factor the 4's further, but we don't need to because at this point we have 3 4's. So we're going to take the 4 out, take the cube root of 64, which is 4, and the 2 is not a perfect cube, so we'll leave the 2 in the radical. With the x's, we have 7 x's. We're looking for groups of 3, so we have 2 groups of 3, so that's x squared, 2 groups of x's, and 1 x left over, so that stays in the radical. Rather than writing out the whole list of x's, what we can do is take the exponent on the 7 and divide it by the index. So we have 7 divided by 3 goes 2 times. 2 times 3 is 6. Subtract that is 1. This 2 is your exponent on the outside. This 1 is your exponent on the inside.